Alrighty, so I am going to switch the slide here. So you should all be now looking at a page that has my little Bitmoji talking to you, and then you can see an original image on the top and 5 other images below. And you can see I'm asking you, it says, how is each of these the same or different from the original portrait of the student? So we're going to be talking about scaled images today. So I'm going to give you 1 minute to just look at this screen, think about your answer, what makes some of these the same and what makes some of them different. And then I'm going to send you to a Collaborate page where we can all talk together. Twenty more seconds to finish up any thoughts you have. If you want to follow along in the book, we are on page 7 and 8, because when I change the slide, this picture is going to go away, but you can find the same images on page 7 and 8. Alrighty, so what makes these 5 images below the same or different from the top one? Try to be as descriptive as you can in your answer and go ahead and type in whatever you may be thinking. So what makes them the same and what makes them different than that original one? As you're posting, if you submit yours, go ahead and read through some of your classmates to see if they're saying the same thing as you. Maybe they're noticing something that you didn't notice. If you may be confused, their responses could help you think through what we are talking about. I like what you guys are saying. Some are the same lengths and some are smaller, or bigger, or wider. The sizes are different. I like what Dustin is saying. Some of them are stretched out. They're slanted, taller, or shorter. Declan is noticing that D is the same as the original and the rest are either smaller, wider, or tilted. This is going to lead us into us constructing our own definition of what we may think it means to be a scaled copy. Okay. So a couple more seconds to finish up whatever you are thinking and to read through some of your classmates' posts. Again, you can continue to see these images if you're in your book on page 8. So some of these pictures that we just looked at, I'm going to go back this way. Some of these A, B, C, D, and E are called scaled copies of the original. So your next question is going to ask you, which ones do you think are scaled copies? And again, if you need to make sure to go back and look at those pictures, you can find them on page 8 in your book. So which of those, A, B, C, D, or E, do you think we would categorize as scaled images? If you need the reference, you can be in your book on page 8. It has those same pictures. Which ones would be scaled images? If you're answering, if you've picked an image, try to now go in and make another post on why you think it's a scaled image. So not only do I want you to choose one and explain why you think it's considered a scaled image. Melina, I'm just reading your comment, and this can go toward anybody. If for some reason you get kicked out or you need to leave the Nearpod, you can follow the link in Google Classroom again, and it's just going to bring you to whatever screen we're working on. Okay, so you're not going to have to redo anything. Just follow the link again, and it's going to send you right back here. All right, so I'm noticing a lot of you are picking letter E as your scaled image. We've got A, B, C, and E. Okay, so I am going to clarify something here. So I'm going to send us back to the images of the pictures. Whenever we're talking about something being a scaled image means it's exactly the same picture it's just a little bit bigger or a little bit smaller. So a scaled copy means that every single piece of this picture got moved by the same amount. So if I stretch it longwise, I'm going to stretch it tall the same amount. So if we go back to our Collaborate page, I noticed someone in here said something about D is the same as the original. The rest are either wider or taller, right? So I would agree here that D is the same. I would pick D as one of my scaled copies because it looks like I took the corner of my original and just stretched it a little bit bigger and moved the length and the width the same direction. So hearing my explanation there, I'm going to send us back to this screen again, and I'm going to see if any of you decide to change your answers. So if D is one of my scaled copies, there's one more in there. So which would the other scaled copy be? Mackenzie, I like your answers. C and D, perfect. Perfect, perfect. D, awesome. It's the same picture, it just got a little bit bigger. So I moved the length and the width exactly the same amount. So you guys were all pretty consistent on this to begin with. You were just picking the ones that weren't your scaled copies. So you were just thinking about it a little bit backwards. If something looks stretched more in one direction than the other, then it's not a scaled copy. E, that slanted picture, I just took it and kind of squished it diagonally. It's not a scaled copy. Scaled copies look like you moved everything in the same direction by the same amount. Awesome. Okay, I'm going to switch the slide now. Now you have the opportunity to answer a question on your own. Your classmates cannot see your answers. So now it's just asking you, what do you think scaled copy means? So you have two options. You can type your answer. If you prefer to just say your answer out loud, you can record it. Again, this is only getting sent to me. Nobody can hear your stuff. Nobody can read your stuff. But just after hearing my explanation, seeing your changed answers, what do you think it means to be a scaled copy? And then once I get all of your answers submitted, if I really like one of your definitions, I may end up sharing it to everybody's screen so that we can all see it. Your name will not be attached, but you might recognize it as being what you wrote. So make sure we're answering the question. What do you think it means to be a scaled copy? If you have to come up with your own definition. I do like this answer, so your screens are going to pause for a second, and you should all be seeing something now. It says if it is the same, just a different size, but not twisted, but just a different size. So I like that explanation. He's talking about it's not squished in any one way or the other. It's all staying the same. I really like this explanation. There's a very good vocab word in here, so I want everyone to take a minute to read through this. It says, I think a scaled copy is the same image, but the proportions are either larger or smaller. It looks exactly the same, just bigger or smaller. I really like that. His use of the word proportion, that's telling us that the width and the length are moving exactly the same. So that is a perfect definition of what a scaled copy is. Both dimensions, my height and my width, are exactly the same. They're both getting bigger or they're both getting smaller. Awesome. Alrighty, so moving on to the next one, you see a bunch of letter Fs. One of them is your original image, and then you have 7 more drawings. So whenever I switch the slide, you're gonna get timed for 4 minutes to work on this screen. What I want you to do is try and figure out which of these drawings are scaled copies of the original. So you don't have to necessarily know the right method to do it. I'm just giving you the opportunity to draw and try to figure out how or which ones of these are going to be scaled copies. So whatever you think that means, which ones would you pick? As you guys are working on this, I can see everything that you're doing. You can circle it, yeah. Whatever you want to do. If you want to do some math, if you want to count some things. This screen is basically just like you doing the work in your book, but I can see it all at the same time. Because right now I can't see if you guys are writing in your math books. But this is letting me go through and see all of the work that you're doing. So which do you think would be scaled copies of the original? So just some time to kind of work and think through what you would have to do. And then I'm going to share with you the process mathematically to figure out which one would be scaled. But as you're working, try and think about the conversation we just had about a scaled copy. If you have come to your decision on which ones you wanted to circle, push yourself to try and think, how can you prove using math that they're scaled copies? So if you circled some drawings, try to find patterns between the original one and whatever you drew. How can you prove mathematically that it's a scaled copy? So a minute to finish up whatever you are thinking. Again, if you have circled it and it's already submitted, try to figure out how to prove it math-wise. How can you show that what you circled is definitely a scaled copy? And then when the minute ends, I'm going to share with you a process to use in order to prove that items are scaled copies of each other. Alrighty, so your time is up. So I'm going to share with you this screen. So you should have chosen drawing number 1, 2, and drawing number 7. So you can see here too some of the work I went through and wrote out to prove that items are scaled copies. For something to be a scaled copy of an original, it means that you can find some sort of pattern between the original shape and whatever the scaled copy is. So if I look at drawing number 2 first, and I'm picking drawing number 2 because the pattern is a little bit easier. First thing I did was went through and counted all of the lengths in my drawings. So my original, I have 4 by 2 by 1, and you can see those numbers around the letter F. So if you notice in drawing 2, all of those side lengths got multiplied by 2. In drawing 7, all of my original lengths got multiplied by 3. And in drawing 1, all of my lengths got multiplied by 1.5. That didn't happen in any of the other drawings. So that's one way to look at the pattern. All of the lengths in your original get multiplied by the same number to create your scaled copies. Another pattern you can see is what I wrote here in red. So notice my arrows. That top piece got multiplied by 2 to create the tall vertical piece. So if I look at drawing number 1, 3 times 2 gave me 6, so I can see the same pattern there, same as in drawing 2 and drawing 7. And I also noticed that the middle piece was half the length of the top piece, which also showed up. So drawing number 1, the middle, 1.5 is half of 3. In drawing 2, 2 is half of 4. And in drawing 7, 3 is half of 6. So in order to prove items are scaled copies, you have to be able to see patterns like that. So either all of the side lengths in the original get multiplied by the same number to create the new drawing, or you can find a pattern within the relation, within the shape as I did, okay? So again, you should have picked number 1, number 2, and number 7. Number 5 was hard to pick. It looked pretty similar. However, that middle piece is not half the length of the top. Neither is drawing number 6. The middle and top are exactly the same length. So I have to make sure the whole shape is following the same patterns I see in the original. Okay, so now on this screen, I'm going to give you the opportunity to go ahead and draw your own scaled copy of F and then submit it once you are done with that. If I like one of your pictures, I may share it with the class. So go ahead and draw your own scaled copy of F. When you're making your drawing, think about what my page looked like that I just showed you. First thing I did was count the original lengths, and then what did I do to make sure it was scaled? So you want to make sure when you're doing scaled copies, you're doing it very precise. Again, I can see all of your screens. So if you're not participating with us, I can see. Another minute or so to finish up. I see some really good answers that I'm going to pick to share out with you guys. Some of us are pretty close. There's one easy mistake to make in something like this. Okay, the first thing I'm going to share out with you guys, I really like this one. So if you notice, what this student did is they took all of their side lengths and they doubled them. So the top of 2 turned into 4, the 4 length going up and down turned into 8, and then the middle piece turned into 2. Perfect way to scale up the side lengths. The only thing we want to make sure we're doing if we're working like this is you need to make sure that middle bar falls in the same place as the original. So what I mean by that, I'm going to share another image with you. Okay, notice what I have here written in red. So my middle piece is halfway through my original. So when I go to make my scaled copy, I also need to make sure that's halfway through my scaled copy. Okay, so if wherever that student was that scaled it by 2, it was perfect. He had the same side lengths, it was great. But we just want to take that middle segment and make sure it's halfway through the tall piece. When I created my scaled image here, I took all of my original lengths and I multiplied them by 4. So 4 turned to 16, 1 turned to 4, and 2 turned to 8. And then I just made sure that all of my segments were in exactly the same spot. Okay? So whenever we're doing scaled copies, you want to make sure your work is looking somewhat like this. So you're taking your time, you're counting, you're doing that multiplication piece. Okay? Here's another really nice one. It looks like this one went through and also multiplied it by 4. Okay? So you can pick any number you want to multiply, but you have to make sure you're doing exactly the same thing to all of your sides. So I'm going to skip through this because we're not going to have enough time. So now we are going to kind of revisit that first question that we talked about at the beginning of class. So explain what a scaled copy is. So thinking about what you said at the beginning of class and now all of this work that we did, how can you kind of deepen your first statement? So what do you think a scaled copy is? Try to use more math language in your answers here. So what is a scaled copy? I like that answer. A copy of anything multiplied by an even number. I'm going to clarify something here because I believe you mean that all of the side lengths have to be multiplied by the same number. I don't want that to be misinterpreted as that you have to pick an even number to multiply by, but I'm assuming that you meant that it has to be even around the whole thing. That third response, I love that one. A scaled copy of something is multiplying the side length by whatever number you choose, and then multiplying the top length by half of what you implied or multiplied the first. So that talks about both things that we saw, taking the original and multiplying it by whatever you wanted, and then finding some kind of pattern within the shape itself. I like this other one, pictures that are same size but doubled by the length. I'm going to alter that a little bit, though. It doesn't just have to be doubled. We can triple it. We can quadruple it. We can use whatever number we want to change that original figure. So a few more of you are specifically saying double. Doubling will make a scaled copy, but it doesn't have to be doubled. I can cut a shape in half. I can multiply it by 3. I can multiply it by 5. Leo, I like your answer where you multiply the width and the length. Perfect. We did a really good job on this page, taking our original answers that we were saying on slide 1, same shape, different size, and putting the math behind it. Being the same size means you're multiplying everything by the same number. Awesome. It has to stick to the same pattern. It needs to be even around all sides. Perfect. Okay, I'm going to switch the slide. You have one more collaborate question. What can you do to determine if 2 copies are scaled copies? So what that means is how can you prove mathematically that something is a scaled copy? So instead of just looking and circling it, what is that math that you have to do to figure out for sure or not whether or not they are scaled copies? Awesome. First step, you have to count the original shape first. Once you count the original shape, you have to see what they're multiplied by. How long or wide it is from the original. Yep. Perfect. Paul, that's okay. Like I said, if you can use the link and rejoin. As a side note, while you guys are adding into this, if you are having a lot of connection issues and it keeps kicking you out of our lesson, I do screen record this. So if you miss a lot of stuff that we're working on after class, I'm going to post it in the Google Classroom so you can just watch the video on stuff that we did. So if you're in that boat where you can't seem to connect or it keeps kicking you out, you can watch our lesson at a later time. It's always going to be available to you. Awesome. You guys are really doing a good time changing your definitions in your work from the beginning. That was our goal here. Really, really, really good. You're all on top of it. Awesome. A lot of you are pointing out that first step, count the original shape. Once you count the original shape, figure out what's multiplied to get your new one. All right, I'm going to switch to bring up our last slide. So it's another drawing slide. So what you're going to do here is figure out which one is a scaled copy, show your work on it. Notice that at the top, it says that it's going to be graded. Please don't stress out about what that means. All it means is that I'm going to go in and look at all of your work. So I'm not going to put it in the grade book. It's not going to be worth points. I'm just going to go in and check to make sure we seem okay with this or if we want to spend a little bit more time on it. Once I get all of your posts submitted, I will quickly put the right answer on your screens, and then we're going to talk about what your independent assignment is. Make sure you're reading all of the directions. I want you to pick which one is a scaled copy and also explain how you know it is. So some of you, I already have them submitted in. Make sure you are also explaining. So circle which one you think it is, and then make sure you also have an explanation. If you're doing some math work and you have a bunch of numbers in your calculations, that can count as your explanation. You can explain using numbers, but just make sure you are explaining. Awesome. A lot of you guys that have this submitted already are right on it. You're on the ball. If you're still working, I'm going to give you until 11:50 just to finish up, just so that I can share out what the correct answer is and give you guys a chance for me to explain what your other assignment is. All right, so your screens are going to pause for a second just so that you can look at the correct answer. So you should have chosen C, which I think pretty much all of you did. So good job for you guys, period 6. And then you can just see my explanations on why some of them did not work. In picture B, I noticed that that top piece is exactly the same length, but everything else changed. So there's no pattern there, so I throw it away. In D, the top piece doubled. So I went from 1 to 2. But then the other segment that I circled did not double. So I threw that one out because there was no pattern. And then a lot of you noticed in C that all of my side links doubled. So that would make it your scaled copy. Okay, so this is pretty much how our lessons are going to work for our units. We'll start out, we'll do some Nearpod. The end of it, we'll end with this question to see how well we picked up on what we were talking about. And then during 10th period is our independent working time. So if there ever is a time where we're working on something during this live class and you are confused, you're stuck, you're not understanding something, use period 10 as that time to pop into the Google Meet to ask some questions about things. All right, so what your assignment is to work on your own, you should have had an Edpuzzle video post to Google Classroom. So you're going to complete that. It's a review of this lesson that we just did with some questions to answer along the way. And then during period 10, another assignment is going to come through where there are just some practice problems. So you're going to work on those. There are going to be answer key videos uploaded to help you in case you're struggling. If you need some help, the Google Meeting Room is going to be open during period 10, so you can pop in and out for whatever you seem to be struggling with, and I'm going to be here to help you. So your goal for the rest of the day for math is watch the video in task number 2, and then work on those practice problems. There's only 4 or 5 questions, so it's not too much. If you're stuck, use the tools that are posted to help you, and then I'll be in here to help you guys. So as long as you're done and you submitted your answer on the Nearpod lesson, you're free to leave. It was lovely having you join today, and I'll see you guys tomorrow.